Welcome to my lesson. My name is Simon, and I would like to take you through stoichiometry of chemical equation. This is to do with ratios in which chemical reactions interact, or rather the ratios in which the reactants combine with each other and also the products are formed. To demonstrate this, I would like us to perform a reaction between iron 2 at dichromate 6, and our objective is to come up with the more ratios between the reacting dichromate 6 and iron 2, and we have all the requirements with me. But before we do the experiment, I would like us to have an example. Like if you have a reaction like you want to react something like hydrogen in gaseous form, you want to react with the oxygen also in gaseous form, so that you can form water, maybe also in gaseous form or liquid, depending on the temperature. Now, if you look at the number of atoms on the left for hydrogen, they are 2. On the right, they are also 2. They are balanced. The number of oxygens on the left are 2. The number of oxygens are 1. So we can multiply water molecule here by 2, so that we can make the number of oxygen atoms to be 2. But that act has made the number of hydrogen atoms on the right to be 4. So we have to adjust also. On the left, we multiply hydrogen gas by 2. We get now 4 atoms on the left hand side. That equation is balanced. Now look at the way the ratios are. We have every 2 molecules of hydrogen reacts with 1 molecule of oxygen, and they produce 2 molecules of water. This is what we are calling the mole ratio, or rather the mole ratios. This shows how the reactants they are combining with each other, and also the products. We have specific quantities of the products which exist in ratios, corresponding ratios with also the reactants, and this we can prove it through an experiment. And when we study this and when we discuss this, we are simply discussing the stoichiometry of chemical equations, and I want us to delve into the practical, and we look at how we can arrive at that. And the requirement we have is we have dichromate solution. We also have iron 2. The dichromate solution is 0.01563 m, and also we have 0.048 m. And this is dichromate solution. Dichromate 6 is orange, and it is an oxidizing agent, and whenever it oxidizes, itself is reduced to chromium 3. Chromium 3 ions are green, so in many cases when it undergoes reduction to chromium 3, this solution turns green, and its concentration, as you have seen, is that one. The other one that we are going to use to study this is iron 2 ions. We have gotten these iron 2 ions from iron 2 sulfate, and the concentration is 0.048. So in our experiment also we have an indicator. The indicator I'm going to use is diphenylamine. We have diphenylamine, and it is the one we are going to use in this experiment. We also have a 25 milliliter pipette. In this experiment, we are going to fix the solution of iron 2. We will put it in the conical flask. So here I have the conical flask where I will put my iron 2 solution, and then from there we are going to start the experiment and you are welcome. And the objective of this experiment is to determine the mole ratio that exists between the reaction between iron 2 and dichromate 6. You are welcome. Let us now start the titration. Let us start. We will start by putting dichromate in the burette. So I'm running down dichromate in the burette. Let me adjust my readings. The initial burette reading now is 2.0 centimeters cubed. 2.0 centimeters. The initial burette reading is 2.0 centimeters cubed. This is initial. We will also take the final. And now I'm going to pipette using the pipette of 25 centimeters cubed, 25 mil. I'm going to pipette 25 milliliter of iron 2. We will put it in the conical flask. This is a conical flask which we will put the iron 2 solution. We will adjust. We will adjust up to the 25 mark. That is where we are. And we put the solution into the conical flask. We put the solution into the conical flask. I want you to remember, to keep remembering that this solution is 25 centimeters cubed. It is 25 centimeters cubed. You are going to react it with dichromate 6. Now I want us to put the indicator, and the indicator that I'm going to put around 2 centimeters cubed of the indicator. So we put 2 centimeters cubed of the indicator. There we are. And I would like us to start titrating. Let us titrate slowly. We move slowly. When you are titrating, open the tap. You open the tap with your right hand side, left hand side, sorry, and you shake the reacting substance in the conical flask with your right hand side. Open with the left, shake with the right. So move slowly. We are almost at the end point. So I'm going to put drop by drop, drop by drop. Maybe 1 drop now will be enough. We expect pink color. Very good. 1 drop, it will be entirely pink. Although it is having some green, so it is having some chromium 3 ions. And finally, there we are. This is the color of at the end point. So we have reacted the dichromate 6 with iron 2, and we have reached the end point. Therefore, the reaction is over. And now we should check the burette. We see the volume that has reacted with iron 2, and the volume on the burette is exactly on the lower meniscus. It is 15 centimeters cubed on the lower meniscus. So the final burette reading is 15.0 centimeters cubed, and that is how we titrate those two substances. Thank you for watching my titration, and we will continue with the rest. Let us now start to calculate. I want to remind you that we had a titration involving two solutions. One solution was the solution of dichromate 6, and the other solution was a solution of iron 2. And in this is a redox titration. Dichromate 6 is the oxidizing agent, while iron 2 is the reducing agent. During the reaction, iron 2 is converted to iron 3, it is oxidized to iron 3, while dichromate 7 is reduced to chromium 3. Dichromate 7 is orange, and chromium 3 is green. That's why during the titration, you observed the solution turning to green before the end point where the solution turned pink. So let us have the summary of what has happened. So this is a dichromate 6 solution, and the other solution was iron 2 solution. Remember that when we are talking about volume, we can only talk solutions. We can only talk about the volume of that solution and its concentration, the volume and its concentration. So let us do the summary of what has happened. The pipette we had was 25 centimeters cubed, and that is what we pipetted. That is 25.0 centimeters cubed. Then the concentration of iron 2 was 0.048 m, while the concentration of dichromate 6 was 0.01563 m. After titrating, we have found that the solution of dichromate 6, which reacted with iron 2, that is the solution that we ran out of the burette into the conical flask for the reaction to take place. The end point reached when the volume which we ran out was 13 centimeters, or rather 13.0 centimeters cubed. How did we get this volume? Our initial burette reading, we got 15.0. You subtract 12.0, and you get 13.0 centimeters cubed. So those are the values that we are going to use to meet the objective of the practical, to determine the concentration, rather to determine the mole ratio of the reaction between dichromate 6 and iron 2. So here we have iron 2. We are reacting with dichromate 6 solution, and they are acidified. So we have agreed this. Okay, this one we have said this one is it looks colorless. Okay, this one is orange. That one is orange. And on the other side, we have said iron 2 is going to be oxidized to iron 3, and dichromate 6 will be reduced, as it is doing the oxidation itself, will be reduced to chromium 3. And chromium 3 is green. Chromium 3 is green. That's why the solution at the end, it was turning green before the end point was reached, which actually was turning purple. So then the other one, we have what? Hydrogen, we have oxygen, all of us, so we are forming water on the other side. So that is the equation we want to build, and we establish the mole ratio that exists between the iron 2 and the dichromate 6 when they are reacting. And let us go. To do that, we need, first of all, to calculate the moles of dichromate 6 which have reacted, and then we calculate the moles of iron 2 which have reacted. We get the ratios, and that is what we are calling the mole ratio, and we will discover that they are reacting with the specific ratios. That is all about the stoichiometry of chemical equations. So moles of iron 2 reacted. The moles of iron 2 reacted. To calculate moles in a volume, this is a volume which has reacted, and we want to know how many moles were in that volume. I told you from the previous lessons, we calculate by, this is 25 over 1,000 multiplied by the molarity, which is 0.048. There we are. We have the number of moles, or the number of particles which have reacted, that they are exactly 0.0012 moles. That is what we have. Let us now calculate the number of moles of dichromate 6 which have reacted. Moles of dichromate 6 which have reacted, they are the volume which reacted. It was 13 over 1,000 multiplied by the molarity, which is 0.01563, and these are the moles which have reacted, moles, and we get 0.000 0.00203. Now, moles. Let us now get the ratio between the two. We want to get the ratio between iron 2 and dichromate 6. The ratio here we have found it's 0.0012 against 0.02032. To get the ratio, we want to know 1 mole of dichromate 6 reacts with how many moles of iron 2. So we divide both sides, 0.0002032. We divide by 0.0000232, and here 0.0012 divided by 0.0002032. Why? We want to see 1 mole of dichromate 6. That is 1 mole of dichromate 6. This is 1 mole of dichromate 6. How many moles is it reacting with of iron 2? So if you cancel here is 1. If you cancel here, you get 6. So you can see that now they are reacting So dichromate 6, from our calculation, you find that they are to iron 2, they are reacting in the ratio of 1:6. And we have established that chemical relationship between the two. Let us now go back to the equation and we insert those mole ratios. So these are now the mole ratios which happens there, or the mole ratios when they are reacting. A mole ratio. The mole ratio. Let us now go back to the equation. Here we can rewrite it down here. In the conical flask, we had iron 2, and in the burette, we had dichromate 6 solution, and they were acidified. And we expect now definitely iron 2 to turn to iron 3, and because dichromate 6 is an oxidizing agent, it will turn to chromium 3. And definitely because of this hydrogen and this oxygen, we will form water. So let us try to balance all of that. Let us try to insert those mole ratios. So here we have found a mole ratio of 1:6 through our calculations. And the question is this true? Look at that. It is true because iron 2 turning to iron 3, we have a loss of 1 electron. And dichromate 6 to chromium 3, we have got a loss of 3 electrons, but these are 2 chromiums. 2 chromiums, each receiving 3 electrons, they will need 6 electrons contributed by 6 iron 2. So definitely, if chromium is changing to chromium 3, and that is true, dichromate 6 changes to chromium 3, then naturally we expect those 2 chromiums to receive 3 electrons each. And naturally, when they receive 3 electrons each, a total of 6 electrons is needed. Iron 2 changing to iron 3 releases 1 electron. So 6 electrons then must come out if we are involving 6 iron 2 and pump those electrons to chromium 6, the 2 atoms there, so that the 2 of them, they can become chromium 3. And you can see that out of that, we have established the relationship between the two, and it's just a matter of now iron here is 6 from the left hand side, chromium here are 2, and the rest is oxygens are 7. So we put 7, and here it is 14. So we have been able to come up with a balanced chemical equation. We have been able to put the mole ratios in this equation through the practical, and that is simply the proof of stoichiometry of chemical equations. Thank you for listening to me.